All right, in an arithmetic sequence, the difference between consecutive terms is always equal. And we're going to write this difference as D, and we're going to call it the common difference. Okay? An arithmetic sequence can be described in two ways, explicitly and recursively. We've already looked at those a little bit. So as you saw earlier, in an explicit rule for a sequence, the nth term of the arithmetic sequence is defined as a function of n. In a recursive rule for a sequence, the first term of the sequence is given, and the nth term is defined by relating it to the previous term. An arithmetic sequence can be defined using either a recursive rule or an explicit rule. Okay? All right, so they give you this example and they ask, write a recursive rule and an explicit rule for the sequence described by each table. So this particular table shows the monthly balance in a savings account with regular monthly deposits. The savings account begins with $2,000 and $500 is deposited each month. To write a recursive rule, you first need to say or state what the first term is. So the value of the first term is 2,000. The common difference is 500 because both of those things are going to go into the recursive rule format. So the recursive rule is f of 1 is equal to 2,000. F of n is equal to the function value of the previous term plus 500. For terms for n is greater than or equal to 2. Okay, so for instance, the second value is going to be equal to the value of the first term in the sequence plus 500. Okay, notice that this whole entire thing is what you have to state to completely state the recursive rule. You have to give the first term, and then you have to give the recursive rule and state it's for n is greater than or equal to 2. All right. Same table, this time write an explicit rule. Okay. So since D is always multiplied by a number that's equal, that's not y'all's bell. Okay, so since D is multiplied by a number equal to the previous n value, you can generalize the result from the table. The explicit rule is going to be f of n is equal to 2,000 plus 500n minus 1. That is the explicit rule for this table. So this table, we've written a recursive rule. For this table, we've written an explicit rule. Okay, they're a little bit different format. Let's try this next one. Okay, another savings account with regular monthly deposits. We're going to write a recursive rule, so we have to state the first term. So the first term is 5,000 and the common difference is 1,000 because they're, I guess, depositing $1,000 each month. So the recursive rule is, and it's got to be this whole thing, you've got to state the first term and then write the rule in the following format. So the value of the term you're looking for is the value of the previous term plus 1,000 for n's greater than or equal to 2. Okay? Write an explicit rule. Okay? And I didn't fill in the table, but it's follows the explicit rule format. So since D is always multiplied by a number equal to n minus 1, you can generalize the result from the table. F of n is equal to 5,000 plus 1,000 n minus 1. Okay, I don't know why they really did this. I think it serves to make it more confusing, but what they did is they put an x here. But what that x is whatever that value is after you do the n minus 1. Okay, so for instance up here, n minus 1 is 1 minus 1. That's where that 0 came from, and they're going to call that the x value. Okay, 5,000 plus 1,000. The n minus 1 is 2 minus 1, which is 1, which is how you get that 6,000. Again, that is not your bell. 5,000 plus 1,000. This time it's 3 minus 1, which is 2, which gives you 7,000. Okay, so I suppose that's what they did, but they really didn't tell you that that's what they were doing when they decided to put in an X. Okay, so I'm now on the next page, page 163. It says Jerome says that the sequence 1, 8, 27, 64, 125 is not an arithmetic sequence. Is that correct? And explain. He's actually correct. It's a pattern of some sort, but it's not an arithmetic sequence. Why? Because there is no common difference. So the difference between 1 and 8 is not the same as the difference between 8 and 27, not the same as the difference between 27 and 64, etc. So it does not qualify as an arithmetic sequence. There's no common difference. It may be a pattern. It probably is a pattern of some sort, but it's not an arithmetic sequence. Okay, kind of ran out of room there. An arithmetic sequence has a common difference of 3. If you know that the third term of the sequence is 15, how can you find the fourth term? Well, I'm going to use the recursive rule. So I know that the fourth term is going to be the third term plus 3, and that's going to be 15 plus 3, which gives me 18. Table shows the number of plates left after a buffet after n hours. Write a recursive rule and an explicit rule for the arithmetic sequence represented by the table. Okay, I'm noticing here to here, I'm subtracting 14. Here to here, I'm subtracting 14. I'm subtracting 14 each time. So my common difference is negative 14. Not 14, negative 14. Okay? So I'm going to write the recursive rule in the format that we've been learning. I have to state the first term, which is 155, and then I write the recursive rule. My common difference, instead of plus, it's minus this time because it's going down for n values greater than or equal to 2. My explicit rule, again, I'm following the format that we've been learning, is 155 minus 14 n minus 1. And then I'm not real sure why they finally get around to telling you, here's your general format, but this is where they decided to give you the general format. These are the formats that we've been following since we started this. It's just they're finally getting around to stating that. Okay? I personally might find it helpful if I take an index card and write these down, because I'm going to have to, until you guys memorize what the format looks like, you're going to have to constantly refer back to this little page. So writing it down on an index card and taking the index card to the subsequent pages is probably not a bad idea.